Okay, hello there. This is How To with Mr. Whately. Today we will be looking at how to find the area of a trapezoid, another extension of standard 7.G4, which is a 7th grade mathematics standard. Okay. So you will be working with area of a trapezoid soon in the upcoming unit, finding the area of basically composite figures. It would be a geometric figure made of 2 or 3 different shapes, and you'll definitely see the area of you'll see trapezoids involved in those problems. The trapezoid, first of all, in order to find the area of it, trapezoid is pretty much defined by a 4-sided shape, a quadrilateral, that has one pair of sides that are parallel. So I drew this one for you, and I highlighted the parallel sides. So this is, in fact, a trapezoid. We're going to assume these green sides here are parallel, and then the other sides go pretty much any which way but loose. Okay? The area formula is a little more extensive than some of the other ones that we've seen. The area formula is 1/2 times the height of the shape times both bases added together. If you've seen that video or the process of where this formula came from, you'd understand why it's both bases added together. Okay? So it's important to understand a few things. The bases in the formula, they're given these little numbers down there by them just to differentiate them. Okay? So there are 2 different bases in this shape. So in the formula, you need to make sure you include each base 1 time. So base 1 could be this or that, doesn't matter, but it has to be one of them. And then base 2 is the other one, the other side that is parallel. So the bases are the sides that are parallel. Now height is a different situation. A height is the distance between those parallel sides. Okay? So if I were to mark out this distance here, let's say we measured it, and we came up with, I don't know, some sort of a value. This red distance here, that would definitely be the height distance. Okay, and another thing, very similar to the triangle, the height runs at a 90-degree angle from the base. Okay, so that's kind of easy to spot. If you spot the right angle there, then you can pretty much figure out that you've got the bases with the height. Okay, so these are the values that we will use and we'll plug into this formula. I like to write the formula a little bit differently. It's always the same outcome usually, and we'll just follow the order of operations to find the area of a trapezoid. Okay, so I've got an example for you right here. Now, be careful with some of these because sometimes there's extra measurements in the diagram that you do not need. So I've written the formula here, and I've already stated that the bases are the sides that are parallel to each other. So these 2 measurements, these 2 lengths will go here. And then the height, as I just mentioned, is the distance between the 2 bases. So I have that in red here, and that'll be the value that we plug in here. So what about this? What about this one, Mr. Whately? What about that one, Mr. Whately? Well, guess what? You don't need those side lengths to calculate area. So when you're approaching some of these diagrams, you have to think and you have to make sure that you're using the measurements necessary to correctly come up with area. Okay, so I'm going to go ahead and find the area of this beautiful trapezoid. Okay, we'll go ahead and do that now. I always like for you to write the formula out. I don't typically write it like this. I usually write it like height times base plus base, all divided by 2, which is, it's the exact same outcome. Okay, so I'm going to take the formula, I'm going to take the diagram and the measurements, and substitute them into the formula. Okay. In this case here, the height happens to be 3 centimeters. And now the bases. Well, the first base is 3 centimeters, so I'm going to plug that in for B1. And then the other base, which I'll call B2, is this side here, and it is 6 centimeters. So I will plug that into the formula. And then I'm going to not forget to write divided by 2. Okay, that's a common error. Students forget to divide by 2. Now we're going to follow the order of operations. The order of operations pretty much requires for us to complete what's in the parentheses first. So I'm going to go ahead and do that. 6 centimeters plus 3 centimeters is 9 centimeters. We're just adding them together so they don't become squared. I'm going to copy this, and then I'm going to definitely copy divided by 2. And we're going to then multiply what we have in the numerator. 3 times 9 is 27. Centimeters times centimeters is centimeters squared, all divided by 2. Okay, so we're almost there. Our final calculation is going to be 27 divided by 2, which will equal 13.5, 13 1/2 centimeters squared. Okay, so when you divide, this right here becomes 13 5/10, and then the centimeters squared remains. So if we were to take this shape, and if we were to draw every centimeter, draw grid lines through it, draw them the other way, we could count them all up. We'd have 13 1/2 exact squares that are centimeters in length on the side. Okay? So that's pretty much how that goes. I thought I'd show you maybe one other example, and it's going to pretty much follow the exact same process. I rotated this trapezoid. This is definitely a trapezoid if you take a look at it. We have a pair of sides that are parallel, and the other sides can go any which way they want. All right? So that means this distance is not necessary. And if you think about it, in this case, if I were to draw a distance between the bases at a right angle, that's just this length right here. Okay? So you could either do this if you want, or just use this distance between the bases as your height. So we have the bases, and then we have the height measurement. So we have everything we need here to calculate the area of this trapezoid. So start by writing the formula: height times base plus the other base, all divided by 2. As I said, in this case, the height is the distance between the bases, so it's 6 feet in this case. It's a big trapezoid. Maybe it's a doghouse. And then the bases are these green sides here that I've highlighted. So one of them is 12 and the other one is 6. Doesn't matter how you put that in, because it is commutative, and the order of the addition does not affect the sum. And then, I almost forgot, all of it divided by 2, or times 1/2 as your textbook likes to show. And then we're going to follow the order of operations. Again, you're going to complete the operation in the parentheses first. So we're going to do that. 12 plus 6 is 18. Feet plus feet is just more feet. All divided by 2. Okay? Now, we're almost done. There's 2 ways you could complete this calculation. You could multiply both of these and then divide by 2. Or because this is an even number, or one of these is even, we could take one of them, possibly the 6, and we could divide it by 2. Or we could take the 18 and divide that by 2. And that would take care of the division. But what I'll do is I'll just complete this like I did the previous example. So I'm going to multiply 18 with 6, and that's going to equal apparently 108. So we have 108, and then feet times feet is feet squared. There's our area units, and we will not forget to divide by 2. That's the big thing that we have to remember. 108 divided by 2 is going to be 54. So the area of this trapezoid, given the measurements, is 54 feet squared. Okay? So that's about all there is to it. Just make sure you follow the order of operations. Make sure you include each base in the formula 1 time. and make sure your height is accurate. Okay? With all that in place, you should have no problem finding the area of a trapezoid. Take care.